This module is all about sequences. A sequence is a series of numbers, and I should say an infinite series of numbers, to which there's an order. Like the list of odd numbers, 1, 3, 5, 7, 9, I could continue this list 11, 13, 15, 17 for as long as I wanted to, but this list is going to go on forever, and there's definitely a pattern to it. While we're talking about sequences, each number in a sequence is called a term. There's two types of sequences. An arithmetic sequence is a sequence where I'm adding the exact same value to each term in the sequence to get to the next term in the sequence. A geometric sequence is a sequence where I multiply the same value to every term in the sequence to get to the next. Taking a look at the sequence 3, 6, 9, 12, 15, and on forever, can you tell what type of sequence it is? Well, since we're adding 3 to each term to get to the next, this is an arithmetic sequence. When I'm asked to find the next 3 terms, that means continuing the pattern. I need to pick up where my sequence left off and find the next 3 terms to follow the 15. Continuing to add 3, I'd get 18, then 21, then 24. To describe a sequence, it takes more than just saying I'm adding 3 each time. That could describe any number of sequences out there. So when you describe a sequence, the two pieces that make this sequence unique is where it starts and what the pattern is. To describe this particular sequence, I could say it starts at 3 and then I add 3 each time. Let's take a look at our next sequence. Since we're alternating from positive to negative, positive, negative, this definitely is not an arithmetic sequence. So we know that this is going to be geometric. However, what if I have a difficult time deciding what I'm multiplying by, right? Deciding what the pattern is. Well, I have an easy way for you to find out. In a sequence, in a geometric sequence, going from left to right, we're multiplying. But that means going in reverse order, from right to left, I'm dividing by that same value. So if you see a sequence and you're having a hard time deciding what the multiplier is, you can go in reverse order and divide. Negative 54 divided by 18 is negative 3. 18 divided by negative 6 is negative 3. And negative 6 divided by 2 is negative 3. That means going in order from left to right, I must be multiplying by negative 3. Just kind of a hint if you're having a hard time deciding what your multiplier is. Since we are multiplying by negative 3 each time, this is definitely a geometric sequence. And if I want to find the next 3 terms, starting at negative 54, I continue the pattern. Multiplying by negative 3, I'd get positive 162, negative 486, and positive 1458. To describe this pattern, again, what makes this sequence unique is not just the pattern itself, but what number it starts with. So we start with 2 and then multiply by negative 3 each time I move from one term to the next. Some important vocabulary for you to know. A sub n is how that's read. Refers to any term in a sequence. A is not necessarily the variable here. A represents any term, and the subscript n refers to the term number. So if I have A sub 1, that refers to the initial or first term in the sequence. A sub 2 would be the second term, A sub 3 the third term, and so on. If I wanted to refer to the 25th term in the sequence, I would write a sub 25. A common difference is the number we add in an arithmetic sequence. A common difference is always represented by a lowercase d. A common ratio is the number we multiply by in a geometric sequence, and a common ratio is always represented by a lowercase r. So let's do just a little bit of practice before we end today. Let's take a look at this very first sequence. Can you tell what type of sequence it is? This one's a little bit confusing if you haven't seen this type of sequence before. It looks like we're subtracting 3 each time. But remember, our two types of sequences only refer to addition and multiplication. This is still an arithmetic sequence, but we would say our common difference is -3. Instead of saying we subtract 3, we are adding -3. Then it asks us to identify a sub 1, a sub 5, and a sub 8, the first, fifth, and eighth term in the sequence. We can already see the first term, but to identify the fifth and the eighth term, we need to extend our pattern just a little bit. Now I can say a sub 1 is 18, and I can count over 1, 2, 3, 4, 5. The fifth term is 6, and the eighth term is -3. So I would say a sub 1 equals 18, a sub 5 equals 6, and a sub 8 equals -3. In our second sequence, fractions usually tend to throw us off just a little bit. If you look at the numerator and denominator separately, it's going to be a little bit easier for you. The numerators, if you notice, don't change. We're definitely not adding anything here, but couldn't we say we're multiplying the numerators by 1? And then the denominators look like they're being multiplied by 2 every time I move from one term to the next. That makes this a geometric sequence since we're multiplying, but since the numerator and denominator are getting multiplied by different numbers, we can make our common ratio a fraction. Our numerators get multiplied by 1, and our denominators are getting multiplied by 2. To find the first, fifth, and eighth term in the sequence, I need to extend my pattern. Then I can find the first term, the fifth term, and the eighth term in my sequence. How about the third sequence? What type of sequence do we have? Definitely arithmetic. What's the common difference? 5, since we're adding 5 each time. And then extending the pattern so I can find the first, fifth, and eighth terms gives me a sub 1 equal to -10, a sub 5 equals 10, and a sub 8 equals 25. Okay, I think that's enough for today. Make sure that you rewind and look through examples again if you need extra help. For now, have a great day, and I'll see you next time.